Right, on planet X, a ball on a massless rigid rod oscillates as a simple pendulum with a period of 2 seconds, just like Earth, okay, back and forth in 2 seconds. If the pendulum is taken to the moon of planet X, where the free fall acceleration g is half as big, the period would be right now. So before we do any calculation here, let's think about this. This is the pendulum period equation, L over G. So what we're saying here is that, oh, the G is going to be smaller. So before we look at the quantitative side of things, what would you say about the period? Would it be longer or shorter if the G it's getting smaller? Longer, right? So if it happens to be a multiple choice, then you know how to choose the, or at least you know which one to eliminate. But how do we know how many seconds that's going to be if we decrease the gravity by half? Okay, now, so let's just say we have this is the old period, which is 2 seconds, right? 2 seconds. So let's go ahead and say, yeah, let's go ahead and calculate the T nu, okay? What's T nu is 2 pi and then L over 1/2 G, right? So let me go ahead and just put down 0.5 G right here, okay? All right, now, how do we handle this conceptual question when we don't have any of those numbers? Now, one way you can do is to hypothesize some numbers. You may say, let me go ahead and use G as 10, use 10 as G, set 1 to L, and calculate it. Or if you can say, let me go ahead and set G to be 9.8 and L is 0.993, and then let me just go ahead half of the 9.8. That works, but I want to show you the conceptual way. How can we handle this? Is that we will go ahead and separate the 0.5 or the square root 0.5 from the bulk of the equation, like this. I hope you can see how these two are equal expressions. We're simply taking the 0.5 away. And then, well, that was the same thing as what we had earlier, right? Which is 2 seconds. So that means we have 2 seconds multiplied by 1 over square root of 0.5, which would likely to be a number bigger than 2 because you are dividing by a decimal number. So 2.02 divided by square root of 0.5, that's going to give you 2.8 seconds as a result. So as you can see right here, we have a lot of these questions. You know, if we double this, how is the other thing going to change? So it's always the same technique. You want to separate the change from the original so that you can see how much it would change from the original. Okay. All right. Next question, number 2. See if you can answer it. I think you can answer it. The answer is? Okay. 2 seconds. Okay. Yep. That's why I asked you earlier, so that you can answer this question.